Today, every physics and chemistry textbook teaches the same fundamental truth. Everything is made of unimaginably tiny particles called atoms. But at the beginning of the 20th century, that idea was not considered established science. To many of the world's leading scientists, it was nothing more than speculation. The man who defended it was ridiculed, dismissed, and gradually isolated by some of the most respected figures in the scientific community. Exhausted after years of defending a truth he could not yet prove, he took his own life. Tragically, the evidence that would validate his life's work arrived just 1 year later. This is the story of the man who knew atoms were real, but could never convince the world in time. To understand this story, we need to travel back to the late 19th century. There, an Austrian physicist named Ludwig Boltzmann proposed a bold and controversial idea. The behavior of gases could be explained if they were made of countless tiny particles, atoms, constantly moving and colliding with one another. Today, this is one of the first scientific concepts taught in school. But in Boltzmann's time, many of the world's leading scientists considered the idea unscientific, almost heretical. At the time, the dominant view in physics was simple. Science should concern itself only with things that could be directly observed. Temperature, pressure, and volume could all be measured. But atoms had never been seen, touched, or directly proven to exist. Influential physicists and philosophers of the era, especially Ernst Mach and Wilhelm Ostwald, regarded atoms as nothing more than a useful metaphor rather than real physical objects. Ludwig Boltzmann disagreed. He argued that atoms were real, and more importantly, that their behavior could be calculated. His work would eventually become the foundation of what we now call statistical mechanics, one of the cornerstones of modern physics. The problem was that he had no way to prove it visually or experimentally. Microscopes of the time were simply not powerful enough. Mathematics was his only weapon. Boltzmann tirelessly defended the atomic theory in scientific meetings, research papers, and conferences. But the response he received was far more than professional disagreement. It became deeply personal. Many of his colleagues dismissed his ideas as mere speculation, while others openly called them nonsense. During one conference, a renowned scientist publicly mocked his theory, and the lecture hall reportedly erupted in laughter. Boltzmann was not completely alone, but he came painfully close. Only a handful of young physicists believed in his ideas, while the overwhelming majority of the scientific community stood firmly against him. This was never just another academic debate. For Boltzmann, it was his life's work. The scientific universe he had spent years carefully building was being dismissed as nothing more than a dream. Years of constant rejection and relentless criticism took a devastating toll on Boltzmann. Historical records suggest that he experienced increasingly severe episodes of depression. His emotional state fluctuated dramatically. At times, he was energetic and remarkably productive, while at others, he sank into profound despair. Following harsh criticism at a scientific conference in 1898, records indicate that Boltzmann began struggling with suicidal thoughts. At the same time, his physical health deteriorated. He suffered from severe headaches, vision problems, and recurring asthma attacks. The burden of emotional and physical exhaustion had become overwhelming. Yet he refused to stop working. Deep inside, he believed he was right. He simply could not prove it. At least, not yet. In the summer of 1906, Boltzmann traveled with his family to Duino, near Trieste, Italy, for what was meant to be a peaceful vacation. While his wife and daughter were at the beach, Boltzmann remained alone in his hotel room. That day, he died by suicide. He was 62 years old. He left behind thousands of pages of scientific work, a revolutionary theory, and a scientific community that had isolated him for years. And this is where the story becomes truly heartbreaking. Just 1 year earlier, in 1905, an unknown young physicist named Albert Einstein had published a paper explaining Brownian motion. It provided powerful evidence for the existence of atoms, the very idea Boltzmann had defended throughout his life, an idea that had been mocked and dismissed, was finally beginning to gain acceptance. But Boltzmann never lived to witness his greatest vindication. In the years following Boltzmann's death, the scientific community finally embraced the atomic theory. Einstein's research, followed by Jean Perrin's groundbreaking experiments, provided conclusive evidence that atoms were real. Today, Boltzmann's equations, especially the famous formula engraved on his tombstone, S equals K log W, form one of the foundations of modern physics, thermodynamics, and statistical mechanics. Every time an engineer calculates entropy or a chemist models the behavior of gases, they are unknowingly relying on the ideas of a man who was once ridiculed, rejected, and left almost completely alone. Boltzmann's story bears a remarkable resemblance to that of Ignaz Semmelweis. Both men defended ideas that were rejected because they could not yet be fully proven. Yet there was one important difference. Semmelweis had statistics, but he could not explain the underlying mechanism. Boltzmann had mathematics, but lacked the experimental evidence to convince his contemporaries. Both paid the price for being ahead of their time. So here's a question worth asking. Which ideas that are dismissed as absurd today might become the accepted truths of tomorrow? Thanks for watching. See you in the next story.